Okay, so as in the last video, we have discussed some basic terminologies which are used in the simple pendulum. We said simple pendulum is consisted of weightless and inextensible string. We know the meaning of weightless, right? Which means it has no weight, right? Secondly, it is inextensible string, which means it is not stretched at all, right? Secondly, it is attached to a fixed support to which a body of M mass is suspended, right? This was our first terminology which we learned in the simple pendulum. Second terminology, the mass M which is suspended to the string is what we call the bob here, right? So mass M which is suspended to the string, right, is what we call the bob, B-O-B, bob. Then we said what three forces are acting on this bob, this MS suspended to a string. We said three forces are acting on it, right? Initial force is tension in the string. We know that this string will have some tension along its, string. So that was the first force. Second force, parallel Wx component of the weight, which is acting downward, and then perpendicular Wy component of the weight, which is W sine theta. In today's video, we are going to derive the formula for finding the acceleration of the simple pendulum, right? We know that Wx component will do nothing. This is Wx component. So this Wx component will be cancelled with this tension. You can see tension is, the direction of the tension is upward, while the Wx, which is W cos theta, is downward. So these both will be cancelled, right? What's remaining? Wy, which is W sine theta. So Wy is responsible for the motion of the pendulum. Since tension and Wx don't work, they are not responsible for motion. We need to see if they are asking what three forces are acting on a bob. Those three forces are tension, Wx component of weight, and Wy component of weight. But what component or what forces are responsible for the motion of the simple pendulum is only a force, which is Wy component of the weight, which is W sine theta. So Wy is responsible for the motion of the bob. So Wy component of weight is responsible for the motion of the bob. Since tension and Wx component don't work, they are not responsible for the motion. Which we can also say Wy component is actually restoring force. Since it will react, it will restore the body towards its mean position. Which means if I find F net, that would be equal to minus Wy. That would be equal to, of course, minus Wy. Now why we have got this minus? Since it is directed towards mean position. It is directed towards mean position. That's why we have put minus sign with it, right? So F net is equal to minus Wy. Now we know that according to the Newton's second law of motion, F is equal to ma, right? According to Newton's second law of motion, F is equal to MA. Let's substitute this value in the first equation. This is our first equation, right? So substituting, the F value in equation 1. In equation 1, right? Then what it becomes, MA is equals to, now see, WY component of weight is equal to what? W is equal to mg, right? Mg. And Y component is actually sine theta. So W sine theta, which means mg sine theta, since W is equal to mg. We can actually mention here W is equal to mg. Okay. So mg sine theta, and with it minus sign, since we have already minus sign with it, right? Now see what is, or what we can cancel here. M cancel with this M, right? So what we have now remaining, x is equal to minus g sine theta. Minus g sine theta. Now see, for small values of angle, for small, this is very important point, you must understand it, since you will get this line in a lot of boards book. For small value of angle, for small value of angle, sine theta is approximately equal to theta. We'll see how this works. What's the meaning of this, right? So let's understand this with the help of sine theta and theta only, right? Let's see their values. Now see, if I have sine 1, we need to take small values of theta, right? Because we have already mentioned, for small value of angle, then sine theta would be equal to theta only, right? So for sine 1, it is approximately equal to 0.0174, and if I take 1 degree, that is equal to 0.0174 radian, right? This we already know. Secondly, sine 2 degree is equal to 0.0348, and sine 3 degree is equal to 0.087. Let's see here too. 2 degree is equal to 0.0348 radian, and 3 degree is equal to 0.087 radian. Now see, for small values of theta, sine theta is approximately equal to theta. Sine 1 is 0.0174, and 1 degree is also 0.0174. Sine 2 is 0.0348. 2 degree is also equal to 0.0348 radian. Sine 3 degree is equal to 0.087, and 3 degree is also equals to 0.087 radian. But if you say sine 30 degree is equal to theta, it is not possible, since 30 is, larger angle. We have already written, for small values of angle, sine theta would be equal to theta. Okay, so now let's, A is equal to minus G sine theta, and we already learned that for small values of sine theta would be approximately equal to theta. So let's substitute this value. A is equal to minus G. Instead of sine theta, we have now theta. So this is the formula for finding the expression, but we can actually derive it, we can actually get more from it, since we know that theta is actually angular displacement, which is equals to linear displacement per unit r, right? So if I put this here in this formula, a is equal to minus g. Now see, what is s here? What is linear displacement here? Let's see. We say this linear displacement is x. So let's put this linear displacement as x upon r. What is r here? Let's see. This is our r, right? Which is equal to length L r. So let's put this r. So this is our actually, or you can put here L. That will be more better. So this is our final formula for finding the acceleration of the simple pendulum. This was all for today.